Okay, so you do need a calculator and pencil so that when I tell you to do some dividing out, you're going to be able to. So we learned yesterday how to find a unit rate. And when we did our unit rate yesterday, we set up the problem. We said what's going to make sense, how should we compare them. So we set up miles over hours, and then we divided it out and we got miles per hour. Well, today what we're going to do is we're going to take unit rates now, and we're going to, if they want us to give them as a different type of measure, so instead of maybe miles per hour, they want feet per second. Or maybe instead of dollars per hour, you want to know how many dollars you make per minute. So we want to learn how can we make those conversions. So there are lots and lots of conversion factors. We're just going to kind of warm up by naming some of them here. Conversion factor is this. So when you say that you have some unit of measure, it is also got another name in another type of measurement. So we know that there are so many hours in a day. We know that there are so many days in a week. We know that there are so many weeks in a year. There's all kinds of conversion. There are all kinds of things, units of measure that we can compare to something else. So one of the conversion factors, our first one, 1 foot equals 12 inches. Or in other words, we could say there's 12 inches in every foot. It doesn't matter which direction we look at this from. Either way, 1 foot is the same as 12 inches. Well, 1 hour is the same as how many minutes?
60 minutes.
60 minutes. There are 60 minutes in every hour. Okay, how many weeks are there in a year?
42.
Mm-hmm.
I think.
Not 42.
36.
Not 36.
48.
Not 48.
Higher.
52. There are 52, yeah. We think typically we say there are 4 weeks in a month, but we know that some months are longer than others and some are shorter than others, and there just turns out that there's an extra 4 weeks in there. We can't just take 12 months times 4 weeks. It doesn't turn out that way. So there's 52 weeks in a year, and does anybody just happen to know how many feet there are in a mile, Riley?
5,280.
5,280, good. There are 5,280 feet in a mile. Okay, that's just some of many conversion factors there are. We're just kind of showing that there are other ways to name something. So if we have to convert from feet to inches, we can say, oh, well, there's 12 inches in every foot. We don't typically say there are so many feet in every inch, do we? Or we don't typically say there are so many days in every minute. Or, days in every hour, or so many hours in every minute. So here are the types of problems we're going to do today, and you only have 5 of them to do. And I'm going to be very strict about this. You will show the steps of multiplying by these conversion factors, and you will write labels in all of your work. No labels, no conversion factors set up, and use no credit for doing the homework tomorrow. Just a bunch of pencil marks on the paper won't cut it. Okay, so we have a cyclist who travels 56 miles in 4 hours. Convert the cyclist's speed to feet per second. Okay, right now, do we know a unit rate for this cyclist? No, we don't have it as a unit rate, but it doesn't really have to be. But what we do need to do is we need to set it up as a rate. So would we put the miles upstairs and the hours downstairs, or vice versa? Would we say 56 miles per 4 hours? Or do you think it makes more sense to say 4 hours per 56 miles?
For 56 miles.
Okay, so we typically talk about hours per mile?
Yeah.
How do we typically talk about speed? Miles per hour. So again, we have to have thoughts like we did yesterday. We have to say, we talk about it as miles per hour, so we're going to put the 56 miles upstairs. We have to have a good start. 56 miles upstairs and 4 hours downstairs. So we want to change this into feet per second. So we need to change the miles to what? What do the miles need to change to? They need to change to feet. And what do the hours need to change to? Seconds. So we have all kinds of changes to make here. So we want our 56 miles upstairs to eventually become feet. And it can't just become 56 feet, because our 56 is 56 miles the same as 56 feet? No. We can't just change the labels. So we have to do something to help us. So we have to go from, it looks like I'm dealing with the time here first. We have to go from hours to seconds, but in the meantime, along the way, there's minutes in between there. So how many minutes in an hour? 60, so we need that conversion. And how many seconds in a minute? 60, thank you. So we can use these two conversion factors to help us get from hours to seconds. And then we have to get from miles to feet, and we can go directly there, can't we? How many feet in a mile? 5,280. So there's a third conversion factor we're going to have to use. We have 3 of them to work with. Now we're going to set them up as fractions, but we can't set them up as we can't decide which order the fractions are going to go until we first start with our 56 miles over 4 hours, and I want it written like this. I don't want you to just put 56 over 4. Include the miles, include the hours. We're going to multiply. We want, and we have 3 different things to do. So we get to start with either the time first or the distance first. Which one do you want to convert first?
Distance.
Distance. Okay, well, if we're going to convert distance, we need the miles to go away. So that means for things to cancel when you're multiplying fractions, one has to be up and the other one has to be down. So that's the first thing I always decide. That's the first thing I always decide. If I need the miles to go away and miles are up, then my conversion factor, it has to be down. So now I go to my conversion factor and see that in 1 mile, there are 5,280 feet. There are 5,280 feet for every 1 mile. Okay, and then that means that right now I'm just going to cross out the miles. That's all we're going to do right now, just cross out our miles. We're going to make this into one big multiplication problem here, okay? Times. Now, we don't want the feet to go away because look at right here, it says we want feet, so we don't want that to go away. So we're going to leave the feet alone. Now we want to get rid of the what?
Hours.
Hours. So that means we need hours upstairs because they're downstairs over here. And we're going to go to, so we'll look at our one that has an hour in it. It has 60 minutes. So we're going to put 60 minutes downstairs and 1 hour upstairs. And what's going to cancel right now?
Hours.
The hours are going to cancel. And so now I look at, and I see I have feet upstairs. That's the only thing not crossed out upstairs. The only thing not crossed out downstairs are minutes. So now I'm going to say, is minutes what I want? No, we want, what do we want?
Seconds.
Seconds. We want seconds. So we're going to put another conversion factor on here. We're going to say times, want the minutes to go away, so they're going to be upstairs. And we're converting now to seconds, so we want seconds downstairs. So I don't think I need an S up here because we're going to use 1 minute is how many seconds? 60 seconds. Okay, again, what our goal was to get the minutes to cancel away. after we see that the only label left upstairs and the only label left downstairs are the two labels we want, we're ready to do our multiplication. So we have feet upstairs and we have seconds downstairs. And we want feet per second. So we're ready to do our multiply. So we're going to multiply straight across. We're going to do, put this on your paper, we're going to do 56 times 5,280 times, what does multiplying by 1 and 1 do? Does it change it?
No.
No, so we don't really have to show the multiplying by 1s. So we have 56 times 5,280 upstairs. And what do we have to multiply downstairs? We have a 4 times, we don't need to worry about that 1, times a 60 times another 60. Now's when the calculator is going to come in real handy, isn't it? Upstairs you're going to multiply what's 56 times 5,280.
295,680.
295,680.
Yep.
Okay, thank you. And what's 4 times 60 times 60? 7,200. Okay, thank you.
No, it's not.
No, it's not.
That's 14,400.
Okay, we're going to go 14,400 instead. Okay. Okay, do we all agree? Need everybody kind of double checking, each of us? Do we all agree with the upstairs product? 295,680. And do we all agree with the downstairs product? 14,400. Okay, remember what was the only label left upstairs? What are these? Right now they're feet. What was the only label left downstairs? Seconds. So for 295,680 feet, it's 14,400 seconds. But we want it per 1 second. Now's when we want to get our unit rate. So remember what was our step yesterday? You're going to show me this before you put it in your calculator. 295,680 divided by 14,400, and what do we get? Does it come out exactly?
It's 20.5 for your repeating.
So let's see, we're going to round to the nearest 10 if it doesn't come out nicely. So let's round to the nearest 10. 20.5. Okay. And our label would be 20 and a half what? Feet per second. So this cyclist is biking at a rate of 20 and a half, approximately 20 and a half feet per second.
It's only fast.
Seems like it, doesn't it? Okay. If it would have been miles per hour, how fast would that have been? How fast was a good miles per hour? If that's what all we would have had to find is miles per hour. Can anybody tell me what it would have been there? 56 miles in 4 hours. Don't be such deadbeats. 56 miles in 4 hours. How many miles per hour is that?
4 miles.
1.5.
No, 56 divided by 4. 14 miles per hour. The way we're typically used to hearing it. So 14 miles per hour. And what they wanted it converted to feet per second. So in feet per second, 14 miles per hour is about the same as 20 and a half feet per second. Okay. So any questions on what do I need to see to count your homework done tomorrow? Before we practice one more. Because you don't have that many of them to do, and I expect this much for them, because when it gets to science and it gets a little more, there's some things you're not familiar with, this will be helpful. Okay, let's do one more. Nutrition, especially sometimes when we start talking about grams and milligrams and kilograms and all those things, and that's what you typically talk about in science, don't you?
Yeah, we'll use it a lot next semester.
Okay. So nutritionists recommend that teenagers consume 1,300 milligrams of calcium per day. Are you doing that?
No.
Convert this to grams per year. So milligrams per day, so we say we have 1,300, let's put that right here, we have 1,300 milligrams per 1 day, that's what they wanted. So we need to get from milligrams to what?
Grams.
Okay, we need to change milligrams to grams. mg is milligrams. These are common abbreviations, so we can use them. mg is milligrams. Grams is just g. And downstairs, do we need to change the days?
Yes.
Yep, they need to be changed to what?
365.
Change those to years. Change day to years. Okay. Well, let's talk about what kind of conversion factors then we can use. We're not going to start our multiplying yet. All we're going to do is pick conversion factors. How many do we even need to use, in other words? So can we go straight from milligrams to grams? Anybody happen to know how many milligrams there are in 1 gram?
Is it like 100 milligrams in 1 gram?
Milli is 1,000. Are milligrams smaller than grams?
Yes.
They are, aren't they? So there's 1,000 milligrams, so we're going to put 1,000 milligrams equals 1 gram. Remember, we have to set it up like this right now because we don't know which one we want upstairs or downstairs yet. So all we're going to say is that 1,000 milligrams is 1 gram. Well, that gets us from milligrams to grams. We don't need to do any more with that. Now, can you think of a conversion factor that will get us from days to years?
365 days is 1 year.
Okay, 365 days equals 1 year. So it's looking like we're only going to need 2 conversion factors, right? Okay, so let's start our work. We start with our original, 1,300 milligrams over 1 day. Labels included. And we have 2 conversion factors to set up. Which one do you want to deal with first? The milligrams or the weight or the time? You get to pick. Weight, okay. Then so we have to multiply by something that will get the milligrams to, the milligrams are up, so we need them down in our conversion factor, don't we? So now we look up at our conversion factor and it says there are 1,000 milligrams in 1 gram. Our milligrams will cancel. That was our goal. And now we're going to multiply by the conversion factor that will change the time. What do we want upstairs? We want the days upstairs because they're downstairs over here, so we want days upstairs. So we say 365 days over 1 year. And now our days will cancel out. And we are at the point we would have grams per year, and that's what we want, don't we? So we go back up and make sure we want grams per year, so we're going to get there, we're ready to do our multiplying. So we're going to say, we have to do equals 1,300 times 365, we don't have to worry about that one in the middle, do we? What do we do downstairs? 1,000. Doesn't really even have to be multiplied by anything, does it? Because it's just times 1. Both of the other ones are 1, so we can just put just the 1,000 down there.
174,500.
474,500?
Yep.
Okay, everybody agree with J.C.? Check her out.
424.
Over
1,000.
1,000. What would be our next step of work?
Table.
No, yeah, we're gonna divide. So we're gonna do 474,500 divided by 1,000. And then we're gonna get that and label it. So what is it?
474.
Yeah, 474.5. And the label is? Go back up to our
Grams per year.
grams per year. Grams per year. So there's, how many grams per year of calcium you're supposed to get? Yeah, sounded better when you only had to get one, well, no, that sounds better than having to get 1,300 milligrams a day, right? That sounds like a lot more, even though it really isn't. Okay, any questions?